Hey, what is up, you guys? I hope you all are doing well. Guys, welcome to another episode on the Incredible Academics YouTube channel. So it's in the morning, and in a couple of minutes I have to report to work. But hey, I thought, hey, let me just go through some trig problems with you guys before I dash off. So this is the problem that I want us to quickly look at. So solve for tan cosine squared theta minus 5 sine 2 theta plus 2 equals to 0. There's also B, which says use the solution to A to find the values for theta between that interval over there. So I want us to quickly go through that. I did look at this problem previously, and it kind of gave me problems, but when you've got time, you can actually try to think, and most of the time it does actually work out. So I took my time. So what we're going to do here, we're going to say, okay, fine, we know for sure that there's only one identity for sine 2 theta. Okay, so we're just gonna focus on changing that for now to sine theta cosine of theta, and plus 2 is equals to 0, and then obviously that becomes tan cosine squared theta, all right, and minus tan sine theta cosine of theta, all right, and then plus 2 is equal to 0. So the next thing that we're going to do here is we are going to turn this into something interesting. All right, because remember the 2 is like 2 times 1. Are you guys with me? And you guys know what's the identity for 1. So tan cosine squared theta minus tan sine theta cosine of theta plus 2, and then the 1 gets replaced by what? Cos squared theta plus sine squared theta. All right, so you can see that we've got 2 cos squared theta now plus 2 sine squared theta equal to 0. So the 2 cos squared theta is going to be added to that, and then it becomes 12 cos squared theta minus tan, let's just say cos theta sine theta, doesn't make any difference, and then plus, you remember the 2 cos squared theta went that side, then here 2 sine squared theta is equal to 0 remains. So you can see that now we've got something that looks quadratic. So we're going to let x be cos theta, y be sine theta. So meaning that now we're going to have 12x squared minus tan xy plus 2y squared is equal to 0. Can you see them? Now we are looking at a problem that looks very much familiar. Okay, what's next? So now what we need to do is we need to vectorize. Obviously we can just get rid of the 2's because this is an equation, so we can divide throughout by 2. Then this becomes x squared minus 5xy plus y squared is equal to 0. All right, so the coefficients of x squared and y squared, 6 times 1, that's just 6. So we need factors of the 6 that will give us a combination of, that will give us minus 5 when we sum them. Okay, so but obviously when multiplied we need to get plus 6, so we must be very wary of the signs that we're going to use. So minus 2 times minus 3 gives us plus 6, minus 2 plus minus 3, right? Minus 2 plus minus 3 gives us the middle term, which is negative 5. The sign is also just as important. Okay, we need the correct sign. So now let's factorize by grouping. So minus 3xy minus 2xy. And you can see that if you were to sum this, you'd get exactly minus 5xy. Right, so it's exactly the same thing. We just broke it down using the factors of the product of the coefficients of x squared and y squared. Okay, so let's go right ahead and factorize now. So we're just going to group 6x squared and 3xy, and then minus 2xy minus y squared. Every time when you factorize, you must be thinking, if you were to multiply throughout with the negative sign here, would I get, back whatever that's up there, because you need to reverse these things. Cool. Now let's check what's the common factor here. 3 is a common factor for sure. X is also a common factor, so now we're just left with 2x, and 3x times 2x, it will give you 6x squared. Okay, and then minus y. Okay, and then common factor here, it's just y. So now we've got what? 2x minus y. So you can see there's 2x minus y here, 2x minus y over there. We also got another common factor, so let's take it out. 2x minus y out, so you're left with 3x minus y is equal to 0. So now what are we looking at? We're going to say 2x minus y is equal to 0, or 3x minus y is equal to 0. So meaning that x is actually equal to y over 2. Alright? Yes? We take the y to the other side and then we divide the y by 2. Or here, x is equal to y over 3. Okay? So, but we know for sure what our x is and what our y is. We said let x be cosine. So basically here that means cosine of x, no, not cosine of x, cosine of theta. Cosine of theta must be equal to y over 2, which is just sine theta. Sine theta over 2. Also, the other equation says x is equal to y over 3, meaning that cosine of theta is equal to sine theta over 3. Sine theta over 3. Now, the question is, how do you proceed from here? This is no, this is no big a deal. So what we're going to do is we're going to divide throughout by, first of all, we can just multiply throughout by 2. We're trying to make, are we supposed to make that the survey formula? Okay, no, let's divide throughout by a thing. I actually wanted to, leave sine of theta in isolation before we actually start, doing the little trick that I want to do. So, okay, let's multiply throughout by 2. This side will multiply throughout by 3. So 2 cosine of theta is equal to sine theta. You guys will see just now, it's going to work out perfectly. So we multiply throughout by 3 this time around. 3 cosine of theta is equal to sine theta. Beautiful. Now what do we do from here? We divide throughout by cosine. So if you divide throughout by cosine, on the left hand side we just left with 2, and then on the right hand side you're going to have sine theta over cosine of theta. And then this side, left hand side, just 3, right hand side sine theta over cosine of theta. But now we actually have an identity for sine theta over cosine of theta. So 2 is equal to what? The tangent of theta. This side 3 is equal to the tangent of theta. Okay, so now we are very much familiar with this problem. So let me just rewrite it so that you guys can see it properly. And then this side, tangent of theta is equal to 3. How do we solve from here? How do we solve, ladies and gentlemen? Okay, you can see that tangent of theta is positive, and according to the cast diagram, tangent is only positive in first quadrant and third quadrant. Okay, so meaning that our theta is going to be equal to 180 degrees plus the reference angle. That's the first reduction formula in the third quadrant, and then the first quadrant is just going to be equal to the reference angle. Okay, so that's what our theta is going to be. So now let's find the reference angle. Reference angle is equals to the arc of whatever trig ratio that you have. This time around we've got 10, and then the absolute value of whatever number that's there. So if it's negative, you turn it into a positive. In other words, you disregard the negative. If it's already positive, well, that's great. You just plug in that number there. So I don't even know where my calculator is. Okay, there we go. So the arc 10, shift 10, okay, and then 2. All right, that gives us 63,43. 63, they say it's not 43, it's 43, but hey, I say it doesn't matter. Okay, and then the reference angle on the other side, remember this one as well, that the tangent of theta is also positive, so we're going to use exactly the same reduction formula. So theta is equal to reference angle, so theta is equal to 180 degrees plus reference angle. So to find the reference angle on this side, we'll do exactly the same thing. The arc 10 of the 3 over there, absolute value of the 3, so we just remove the 2 there, plus 1, that becomes 3. Then our answer is now 71.57 degrees. Okay, beautiful. So we are almost there, although it's taking a little bit of time. But so now let's find the theta this side. So theta is going to be 180 degrees plus 63.43 degrees. Guys, remember the period for 10, 180 degrees times k. So we attach the period there, and this becomes what? 180 plus what? That's 243.43. I hope that's correct. Plus 180 degrees k. And then theta is also equal to just the reference angle, and the reference angle is 63.43 degrees plus the period times the integer k. So we're done with this one. We've got the two general solutions. Now let's check on the right hand side. So theta is going to be just the reference angle, which is 71.57 degrees plus 180 degrees k. Remember, k is an element of what? Integers. So theta is also equal to what? 180 degrees plus the reference angle, which is 71.57 degrees plus 180 degrees k. And then we then sum the two. 180 plus 71.57, there we have it, which is 251.57 degrees plus 180 degrees k. And ladies and gentlemen, there you have it. So we've got the four solutions now. Let's just put them in order. We've got theta is equal to 63.43 plus 180 degrees k. Theta is equal to 71.57 plus 180 degrees k. Oh, you guys can see. Okay, another one is theta is equal to 251 43.43 plus 180 degrees K, and we also got theta is equal to the last one, 251.57 degrees plus 180 degrees K, and K is just an integer. So the big question is, how do you answer the second question? Because remember what they said, we were actually asked to find the solution. Remember, we just managed to solve this equation. We managed to solve that equation, but now the problem is that we still need to go right ahead and find the solution that lies between the two intervals, within that interval, all right, between those two angles there. So now let's go right into it. So we're given the interval minus 270 degrees and 180 degrees. That's what we're given. So what you're going to do is all right, so normally we would say we would arrange the solutions like this, okay, although it's gonna seem a bit, I don't know if that's gonna fit. Okay, so we're going to have we can say, okay, K values, we can allow them to range between -3, -2, -1, 0, 1, 2, 3. All right, those are the K values. And then here we just plug in our solutions. So remember, we had solutions, we had 63.43 degrees, also at 71.57 degrees. We also had 243. So now we're on a search, I think they call it an expedition. We're on an expedition. 243.43. Lastly, we've got 251.57. So 251.57. 251.57. So we're just going to keep on adding 180 degrees times the K. It's 180 degrees K, 180 degrees K, plus 180 degrees K. All right, so finally, guys are going to see what we use the K for. Sorry, I don't have a ruler. So remember, K is here. K is -1, -2, -3, 0, 1. I mean, at 0, we know for sure it's going to be 63.43. In other words, when we substitute 0 in place of that K over there, okay, in place of that K, if you substitute 0, you get 60. And here you're getting 71.57. And that's degrees, of course. And here you're getting 243.43 degrees, which is not in our interval. This is outside that interval. Okay, so that's a problem. Even 251.57 right degrees is also not within that interval. Okay, remember the maximum is 180 there. So meaning that if this is already out, whatever that's going to be here is going to be out as well. All right, it's going to be out. You can try it out, you will see it's going to be way beyond that. You substitute your value of K there for each row. So I already know that it ain't gonna work out. Okay, so I'm not about to waste my time. Even here, it's not gonna work out. It's not gonna work out. But let's see here by -1. All right, so in other words, in place of -1, we substitute what? So 63.43, right, this plus 180 degrees. I'm just going to substitute -1 in place of the K, -1, and that gives me -116.57 degrees, and this is within our interval, so this gets a tick, even that gets a tick, that gets a tick. All right, So let's try that one out and see what we get. So in place of that k there, we substitute -1 and see what we're getting. So 71.57 plus 180 and then -1 there. It gives us minus 108.43. I thought we were gonna do, you know, 2 problems, but it seems like, hey, this is long. I'm pretty sure you guys understand now why I didn't want to do this problem, because yeah, it's flipping long. So 243.43 plus 180. So we here now. We're just gonna substitute -1 and find what's here. -1. There we have it, and that gives us 63.43, which is a solution that we already have. You know, 63.43, we already have that one. So let's go to 251 and substitute -1. So 251.57. That also gives us 71.57. So we already got that one. Okay. So let's see if you substitute -2. So here, if you substitute -2, let's see what we're getting. -2, we're getting minus 108.43, and that's a solution that we already have. Okay. And then let's substitute -3. Okay, now this is out because it's -288. All right, that's beyond minus 270 degrees. So cool, let's focus on this column. So 243.43 plus 180, and then we substitute -2. Eventually going to substitute -1. So minus 116.57 degrees. Seems like we're not getting unique solutions anymore. Let's substitute -3. Okay, that's too big, it's out. So this column here, right, that column over there, we're just going to say 71.57 plus 180 degrees k, and our k is -2. It's -2, remember. So -2 over there. What are we getting? It says minus 288.43, which is out as well, and obviously this one automatically is out. And then last one, 63.43 plus 180 and then -2. -2. Any unique solution? This is too big. Well, it says minus 296.57, so it's way beyond minus 270. So this is out, and immediately when this is out, that's also going to be out. So now let's check how many unique solutions do we have. So theta is going to be 63.43, right, minus 116.57 minus 108.43, and we're going to have as well 71.57. I don't know what's happening to my voice, but it seems like it wants to disappear. But anyway, yes, I think these are the unique solutions that we have, and the rest is just, you know, a repetition. So these are the solutions that fall within that interval there. I might not have, you know, picked up some of the solutions, but yeah, I feel like this is it. So we've got 1, 2, 3, 4 solutions which lie within that interval, and we used the general solution to find the particular solutions. Ladies and gentlemen, that's it for today. I hope you guys enjoyed the video, and all the best. Peace out.